It's been a while since we checked in with our intrepid band of explorers as they went their way through the solar system. So let's see how they're doing. In addition to sending humans to the moon, NASA's also sent a lot of robots on one-way trips to other worlds. I mean, space is big, so it makes sense that we can't just pop over to other planets for a quick visit. If we did that, we'd have to spend most of our lives on the bus to get there. Instead, we send robotic probes which can travel much faster than we can and do unneed to worry about things like air or gravity or, not dying. That said, the craft we send do need to be pretty rugged because they'll often run into things. Welcome to the channel. It's been a while since we checked in with our intrepid band of explorers as they wend their way through the solar system, so let's see how they're doing. We left them heading out of the asteroid belt and into the cold emptiness of the outer solar system. And while they haven't quite reached the next stop on our tour yet, we can at least see them getting close. First up, let's check in on Voyager 1, the farthest out craft humanity has ever sent. As of February 2023, it's been traveling for over 47 years and has passed the 15 billion mile mark from Earth. And in August of 2012, it officially entered interstellar space. Voyager 1 was launched in 1977, meaning it was still in diapers when the first space shuttle flight happened. It was designed to study the planets Jupiter and Saturn, but it had some extra instruments that allowed it to detect cosmic rays. This data helped scientists understand how these rays form and gave them insight into the heliosphere, the bubble of space dominated by the solar wind that extends far beyond the orbit of Neptune. In fact, the Voyager probes were the ones that discovered the heliopause, the edge of the heliosphere, and therefore proved that interstellar space actually existed. But because it's carrying only enough fuel for a grand tour of the gas giants, which famously visited Pluto in 2015. But unlike the Voyagers, it wasn't built for a grand tour. It was built for a Pluto flyby. After launching in 2006, it took the fastest route to Pluto, swinging by Jupiter to gain speed using the gravity assist technique that Voyager 2 used to turn itself around. But after seeing Pluto and its 5 known moons, New Horizons didn't just head home. No, it found a new mission. In 2019, it flew by a Kuiper Belt object named Arakoth, formerly named Ultima Thule. The mission was extended again in 2021, but this time it's an observation of Saturn. New Horizons will make multiple close passes in the next few years, taking advantage of the fact that Saturn is going through one of its infrequent ring plane crossings. The hope is that it can help explain how Saturn's rings formed. But what if I told you we have another craft in the neighborhood, something that launched the same day New Horizons did? Enter the Twin Stereo Probe's Solar Terrestrial Relations Observatory. They launched in 2006 to study the Sun and its effects on the solar wind and the heliosphere, and their journey to the outer solar system has been a little different from the others. See, the twins weren't built to go anywhere near the outer planets. They were much smaller than the Voyagers or New Horizons, and lack the power and shielding needed to survive a close encounter with anything more massive than a small asteroid. So instead of a grand tour, they made a series of close encounters with various planets, each one adding a little delta V to their velocity, until they ended up in heliocentric orbits. This means they now orbit the Sun, but lagging behind the Earth by about 6 months. Because they're essentially orbiting the Sun at slightly different speeds, they can sometimes see things that would be impossible to see from Earth, like the Sun's North Pole. These perspectives have given us unprecedented views of coronal mass ejections, the bursts of energy from the Sun that cause auroras on Earth and mess with our telecommunications and power grid systems. And they've even been able to observe the solar wind hitting the interstellar dust clouds at the edge of the heliosphere. Eventually, they'll find their way back to Earth, but don't expect them to come in for a landing. Let's go back to the asteroid belt. You may have noticed that I left out the asteroid belt proper when I talked about the inner solar system in our last episode. Well, it's mostly empty. For most of human history, it was mostly empty. It wasn't until 1991 that the first probe to orbit an asteroid got there. That'd be Galileo, after it dropped off the atmospheric probe for Jupiter. But since then, we've sent several others, including near Shoemaker, which flew by Eros in 2000 and became the first space mission to successfully rendezvous and land on an asteroid. Then there's Dawn, which after studying Vesta and Pallas, became the first space mission to rendezvous with, land on and map multiple asteroids. More recently, we've got OSIRIS-REx, which spent almost a year orbiting asteroid Bennu before collecting a sample and heading home. It dropped off the sample return capsule on September 24, 2023. By the time this comes out, the capsule should have landed and will finally get to study some real asteroid dirt. Of course, we already got some results from the OSIRIS-REx before it left Bennett, like confirming that the asteroid did indeed have a past encounter with Earth. And speaking of impacts, let's talk about DART. That's short for Double Asteroid Redirection Test. It was designed to test the possibility of deflecting an asteroid by crashing a spacecraft into it. So after visiting several other asteroids, it picked a suitable candidate, Dimorphos, which orbits a larger asteroid named Didymos and smashed itself into it at about 14,000 miles per hour. According to NASA, the impact increased Dimorphos's orbital period by 32 minutes. Well, within the margin of error range of the models that predicted the change. And while it wasn't exactly a showstopper, it does mean we may be able to defend ourselves against future world-ending asteroids. Maybe, of course. That's nothing compared to the kinetic impactor missions like Lisa J. Grosso, which slammed into an asteroid on purpose, and IDA, which researchers are currently trying to slam into one right now. Yes, we're actually sending another probe out to join our intrepid travelers. It launched on November 24, 2021, and if all goes well, it'll smash into its target asteroid in September 2024. The goal is to test the spacecraft's ability to navigate in deep space and get some more data about the structure of asteroids. And hey, if we can't reach the asteroid, we'll learn something about asteroid distribution in the inner solar system, too. Either way, we win. And remember, as long as humankind survives, we can always send more spacecraft. It's not like we're running out of planets or anything. Join us next time as we tour the outer planets, because we left the best for last. If you liked this video, be sure to subscribe and leave your feedback in the comments below. We'll see you next time.